So this is our free response problem number 172. This one does require a graphing calculator. You can see that here. And I want to go ahead and let's read through it. We'll make some notes on the screen, and then one at a time we'll address the four problems that are associated with this particular free response question. When a certain grocery store opens, it has 50 pounds of bananas on display. So that's going to be an important initial quantity there. Customers remove bananas from the display at a rate modeled by f of t. So f of t is a rate. It's a derivative. And that particular function applies for t 0 to 12. F of t is measured in pounds, and t is the number of hours since the store is opened. After the store has been open for 3 hours, so starting at 3 hours, employees start adding bananas to the display at a rate, so this is another rate, g of t. And there's that function there. And this one applies from 3 to 12. It doesn't kick in until the third hour. G of t is still measured in pounds per hour. Did I say measured in pounds on the other one? Yeah, these are both measured in pounds per hour. And t is the number of hours after the store is opened. And we have 4 questions that we're going to answer. How many pounds of bananas are removed from the display table at the beginning of the first 2 hours the store is open? And we're going to focus on letter A on the next slide, and then we'll move on to B, C, and D. So I just made the question a little smaller so that we have more room to work here on the slide. We are focusing on letter A here, which is how many pounds of bananas are removed from the display during the first 2 hours the store is open. Okay, so remember f of t is the rate at which these items are removed, these bananas are removed. So if we want to count up how many pounds of bananas are removed, we're going to need to use accumulation. We're going to need to accumulate that change over the course of 2 hours. So the pounds of bananas, which I'm just going to call B, that's going to equal the integral over the first 2 hours of f of t dt. And because calculator is required for this one, we can use our fnint function on our graphing calculators to crank this thing out. And so I've already done that. And sure enough, I came up with 20.051 pounds. 20.051. Remember, we want to write our answers to the thousandth, so 3 decimal places. So 20.051 pounds of bananas. That's what we're talking about here. Oops. And this is an accumulation of the bananas that are being removed by the customers. Okay, let's move to the next slide, and we'll crank out letter B. So for letter B, it says find f prime of 7. Using correct units, explain the meaning of f prime of 7 in the context of the problem. Okay, so remember f is given above. And if we want to do f prime of 7, again, we can use a feature of our graphing calculators, the numerical derivative or nderive. I believe it's Math 8 on the calculator. And you can simply type in the function, type in the variable, which for us is going to be x or t, whichever letter you're using, and then type in 7, and it'll crank out the value for us. So f prime of 7 turns out to be negative 8.120 when you round it off. Now, this is the derivative of f. F is measured in pounds per hour. This is pounds per hour squared. This is pounds per hour squared. And what this means is at 7, this rate is actually changing at negative 8.120. So this is kind of like the acceleration for our function for bananas being removed. So I'm coming up with negative 8.120 on that one, pounds per hour squared. Okay, let's take a look at letter C. In letter C, the question is the number of pounds of bananas on display on the display table increasing or decreasing at time t equals 5? Well, the way we find out if something is increasing or decreasing is we look for whether or not the derivative, right, the rate of change, is positive or negative. So we're going to basically look at what's happening with f and g at t equals 5. What I mean by that is we need to say we have at time t equals 5, we are bringing in g and we are removing f. And if we compute that, it's either going to be positive or negative. If it's positive, then the number of pounds of bananas on the table are increasing. If it's negative, they're decreasing. And again, we can use our graphing calculator to compute this. We just need to compute the two values. So we'll plug 5 into G and we'll plug 5 into F and subtract them. And I came up with negative 2.623. Excuse me, 0.2631. Nope, 0.263. I said it right the first time or the second time. One of those times I said it right. Negative 2.263. Okay, so as I mentioned, because this is negative at t equals 5, the number of bananas or the pounds of bananas on the table are decreasing. Essentially, we have more going out than we have coming in. Okay, we're almost done with this thing. Let's go to that last question. Okay, let's answer letter D. How many pounds of bananas are on display at time t equals 8? They want to know how many pounds. So this is not about the rate of change. This is about how many pounds are actually on the table. Okay, so this is from 0 to 8 that we're worried about here. We start with 50 pounds. And then we start taking away. And we do that with function f. So we're going to accumulate the amount that's taken away over the first 8 hours of f of t. But we start adding on starting at 3 hours. And we need to add on how much we added. I guess that's funny, but we need to incorporate the pounds that we're adding back into the table between 3 and 8. And that's of g of t. So we start with 50. We take away over 8 hours this definite integral, and we add in over 5 hours this definite integral. When I did that computation, I came out with the number of pounds currently on the table at 8 hours at 23.347 pounds. And that's at after 8 hours. 23.347 pounds after 8 hours. Now I'm highlighting the answer, but I mean, you all know that what I'm really concerned about is, do you know to write this out? Because this guy right here tells a story, just like on those other slides. Cranking it out on your calculator is an important skill, but the important part is knowing what to type into your calculator. And so getting this thing set up so that you can let the machine do its magic is really what we're shooting for. Now, you can do all these problems on your graphing calculator, but there are other tools that you know. So we've worked with Desmos in class, and I actually kicked out all these problems just on one Desmos graph And I want to show you a picture of what I did there just to wrap this presentation up. So one by one, I just entered these functions and then did some calculations. So you can see in the beginning we needed to work with function f, so I put it here. And then to answer that first question, I just slapped it in the definite integral and the answer popped out. I can get the derivative of f pretty quickly right there. Doesn't give me the units, but it at least tells me what the value is. Later, we needed to add in function g so that we could do this calculation. There's my answer there. And then finally, here's that last thing. And the cool thing about the Desmos calculator is as soon as you're done typing, the answer pops up. Not only that, but notice we get a pretty interesting picture here. You can't see it, but here in the definition of these two functions, I entered in the intervals, the domains of those functions. So the red one is f, and it's good over the first 12 hours. And then here's g, which only starts in after the third hour. So you can kind of see how the graphs of these functions fit into the picture. But I just wanted to show you this because there is a way to just crank these answers out, similar to what you would type into your graphing calculator, just another tool that we can use to get the solutions. Hopefully this helped clarify the answers that I've been sending to you. We're going to continue to work on these free response problems and hopefully get prepared for that AP test. Take care and good luck.